A-Level Pure 1, Functions, Domain and Range. Let's see what the domain and range of a function is. First, a function is a relation that uniquely associates members of one set with members of another set. So for example, supposing we have a group of people and they take a test which gives marks out of 10. The first set is the set of people, and the second set is their set of marks. Now actually Patel was absent, so he did not get a mark. So the people who got marks, John, Sarah, Sareen, Ali and Lisa, form what's called a domain. Now the second set is all the numbers between 0 and 10, but only 3 numbers actually appear in the list, 5, 6 and 8. This set of numbers is called the range. Now we can draw this in a diagram. We can draw the set containing all the people and the set containing all the numbers between 1 and 10. We can join the names with their marks. So John 5, Sarah 8, Sareen 6, Ali 5 and Leah 8. We can see that only some of set 1 have links. The set with links is called a domain. We see that some of the set 2 have links. The subset with links is called a range or codomain. The important thing is that each element in the domain only has one link coming from it, and each element in the range can have more than one link to it. If the function is what's called a 1-1 function, then each element in the range can only have one link to it. Now we can draw a graph of a function. This function can be represented as a graph. We draw the names of the people, set 1, along the x-axis. Patel should not really be there because he's not actually taken the test. And the numbers 0 to 10 are drawn up the y-axis. And then for each person you can put a point to represent their score. So John has a point at 5, Sarah at 8, Sareen at 6, Ali at 5 and Leah at 8. So again, the important thing is that each name can only have one point above it, but each score can have more than one point across from it. The domain of the function is the set of names below one of the points, John, Sarah, Sareen, Ali or Lisa, and the range is the set of numbers across from one of the points, so 5, 6 and 8. Now functions can often be written as a formula. The numbers in the domain can be represented by x, and the numbers in the range can be represented by y. So you might have a function such as y equals 2x minus 3. If we're given a value of x, let's say x is 3, then we can work out what y is. It's 2 times 3 minus 3. Y would also be 3. Now in this example we've got to draw the graph of the function y equals 2x minus 3 for x lying between 1 and 4. We're then asked to state the domain and the range. Well, to solve this, the first thing we do is draw the graph, and it's a straight line graph. It only extends from x is 1 to 4. Now to find the domain, we look vertically above the line or vertically below the line to the x-axis, and we see that the area that's shaded is from 1 to 4. To find the range, we draw horizontally across from the line to the y-axis and shade it, and we see that the shaded region goes from -1 to 5. So the range is y is between -1 and 5. Let's look at another example, example 2. Draw the graph of the function y equals x squared minus 5x plus 5 for x lying between 1 and 5. Also state the range of the function. Now we can plot the graph and see that it's part of a parabola. Now the domain is the range 1 to 5. But to find the range, we need to draw horizontally across from the curve to the y-axis. Now in the previous example, all we needed to do was draw horizontally from the first point on the line to the last point on the line. But in this case, the first point on the curve is not the lowest point. So we need to find the lowest point on the curve. If we go horizontally across from that, we can see that it shades the region from 1 down to just below -1, and then it shades from the point just below -1 up to the point 5. So the important thing we need to find out is what is the minimum point on the curve. Now we've got the curve is y equals x squared minus 5x plus 5, and we need to complete the square. So we rewrite the equation with a large gap before the plus 5. Now to begin with, we take the number in front of the x, that is minus 5, we halve it, we square it, we add it on, and then take it away again. So that gives us y equals x squared minus 5x plus, and then minus 5 over 2 all squared, plus 5 minus 5 over 2 all squared. Now the first three terms factorise as x minus 5 over 2 all squared, and the last two terms simplify to plus 5 minus 25 over 4. So we've got y equals x minus 5 over 2 all squared plus 5 minus 6 1/4, and we can write that as y equals x minus 2.5 all squared minus 1.25. Now we can see that x minus 2.5 squared is always greater or equal to 0, so y is always greater or equal to minus 1.25. So the curve has a minimum of minus 1.25, and that's when x equals 2.5. And so we can see from the graph that the function on the y-axis lies between minus 1.25 and 5, and that is the range.